So these larger systems are being solved by using analogous elimination techniques. And what we need is to get rid of some of the variables, such as x or y or z. And after we do that, our goal is to find all three of them. So you can see how they've been solved here. So maybe I can just follow with this system of equations here on the margin, and then we'll see how this is similar to the one we have, the solution we have provided here on page 705. So let me just work it out. So it looks like there are three equations and there are three unknowns. So first equation is x and y and minus z is equal to -1. Next equation, I need to work out such a way that x term will be canceled. Please notice that this is a very convenient to have x here because we can easily produce 4x from it to cancel this positive 4x with then negative 4x. But I need to keep the structure. I need to not get lost. So what people do is they copy this whole system just to make sure that you keep it all in one place, because it's very easy if you start to write your solution one place and the other part in the other place, then you might kind of get lost in all that. So first of all, I copy this system, and then I'm gonna need to eliminate letters. And what people usually start with doing is eliminate unknown letter x. And they keep x in the first equation, and then they want the other equations to start with zeros, just like they have here. So here they have 0x, so it disappeared, and there they have 0x. And that's going to be the goal. So how to produce 0x, in other words, nothing in those two positions? Well, it looks like my first equation will stay unchanged. And then for the second equation, I need to have a negative 4x in front. So what people do is so what I need again is negative 4x in front of my equation. So this way, when I collect it with 4x underneath, minus 4x and 4x will cancel, and we're going to get a 0 that we need. And I need to pay the price for that. I need to multiply the negative 4 by each term of my first equation, and then collect these with the terms down below. So I'm only working right now on first two equations, and now I need to see what happens with y. Well, minus 4 and minus 3 will be negative 7 times y, and please notice that's exactly what they have here. The next part will be negative and negative. Negative 4 and negative z will be positive 4z. So 4 and 2 will be 6 with a plus sign, 6 times z. And that's exactly what they have here as well. And this is great. So finally, I'm going to take a 4 times 1 because negative disappears. So we just get the number 4 with 16. When I add 4 and 16, I get 20. And this is exactly what's on my right side. So that's the idea of this little process that they also have here for us to consider. So now when I'm done with the first equation and the second, now I'm going to be doing analogous process with the next, with equation number 3, and still use number 1. So I'm going to be using first and third. And that's the plan. And that's why it's important to stick with this standard process, because lots of times people simply just get lost. So I'm gonna do a couple of problems today just to start with this. I know it's tedious and lengthy, and well, we just need not to hurry. So -2 should be with x because I need now to cancel that 2x. So to cancel it, I need -2x. So that way I will get 0, right? So that's going to be my starting part. So I'm going to use -2. Usually people use parentheses to show that it's like multiplied. It's not subtracted. So you can put -2 in the parentheses, and it's also times -1. And now I care only about the third equation, first and the third. That's how we go about this. So what's with y's? Well, it's -2y and -2y. It looks like -2 and -2, when you collect them, it'd be -4 multiplied by y. And it looks like that's exactly what they have here. And this is a great start. So now we move to z's. And we have a -2 and -1. It's 2z, positive 2z, and -3z. So minus and plus. So I'm going to be subtracting from 3 to I get a -1 times z. And that's a minus z. That's what we have here. So it's nice to have a sample underneath, of course. So then I go with the numbers. So +2 and +5 give us +7. So it is not really that hard, but I guess one needs to get used to this process. So the point is to produce zeros under x, and then we're going to do analogous procedure, but only with the last equation, because it already nicely starts with a 0. So if I kill that 4y term, that'd be just what I need. So I'm gonna go ahead and copy x plus y and minus z is equal to -1. Next equation is also fine. It's a -7z and 6z is equal to 20. And now my goal is to basically solve this little system with 2 equations and 2 unknowns. And notice that it's not very convenient to deal with y's because 4 and 7 are not friends. It's much better if I just cancel the z term first. So if I was able to use 6, right? So it'd be +6z and -6z. So they will nicely cancel each other. So I'm going to multiply by 6. How do I multiply it? Put here, and then parentheses, make sure we multiply like that. And again, we just deal with last 2 equations. So I just keep the structure, keep that first equation, even though it doesn't participate anywhere. And 6z and -6z will disappear. So all I need is just y's, and this will be -7, and then 6 times -4. See, I'm multiplying 6 by 4. It's 24, and I need to add it with 7. 24 and 7 is 31, and it'd be 31. So I put plus or minus, whatever, doesn't matter. 31 times y, but notice that this is negative. Right? Don't forget it's a minus. Again, -7y. Let me write it here so you better see. And next will be 6 times -4. 6 times -4 is -24 y's. So it is -31 times y. Okay, so looks like that's what we produced in here. And analogously, now I go to the right sides and deal with numbers. 7 times 6 is 42. I can write it here, or you can use a calculator and add it with 20. So the sum will be 62. And this is great because this is a friend of 31. Do you see that? 31 and 62 work very nicely with each other. So that 0 means nothing. And I can say that y is equal to what? Negative number 2. And that feels good because now, remember, I'm solving this little system that I just highlighted, and the last equation tells me that y is equal to 2. Now I'm going to use it by plugging in the equation above in the second equation. And then I go up and use the first equation and get the third number. So what's in the second equation? Well, it's minus 7y's. And notice that instead of y, we're to use a negative 2. So just plug in like we did last time. So I don't pay attention to the first equation. I just use the next one, second. And then it's 6z. So I just put it down the way it is. And it's equal to number 20. Okay. Looks like there's not much room. So for the next exercise, I need to take a bigger board because it's not convenient. So anyways, what do we have here? 14, right? It's a 14. Maybe I'll better write it here on the right side, on the left side. So it's a 14 plus 6 times z is equal to 20. And now I need to find z, and that's our old favorite. I'm sure you're an expert in this already. You just need to bring this 14 away, subtract it, and give you 6, and that's awesome because I love these whole numbers. It's not always the case. We already know that. Sometimes you get fractions, so it's always a blessing to have whole numbers. And we get a 1 in here. And then finally, we need to find letter x, and notice that's what they're doing in here eventually. So they found here y is equal to negative 2. They found that z is equal to 1. And now they're going to take this very first equation. So it's x plus y minus z is negative 1. And then go ahead and replace. So 1 I plug in here for z. So increase that. 1 instead of z. And then also we found letter y. Y was negative 2. Okay. So I'm going to replace my y with a minus 2. But just plug them in the way they are. And see what we have. It's minus 3, so I need to add 3 on both sides, looks like, right? So you can solve it any way you like. If you have some other way in mind, use it. As long as you get the same answer, we're fine. So we produced x, which is number 4. And this is, I hope, here. I say, Alex, I got a 2, not 4. So what happened here? Well, I guess I need to be a little bit more careful, right? So what happened there is I didn't write it down carefully. What that means, I lost the minus. Notice that it's a minus in here. So Alex, okay, I see it's a minus. Yeah, I better just write it. So maybe it's a good thing that I didn't do it right, because I hope it shows you that when you start saving some room, you may lose a sign, and that will definitely not give you the answer you need, because it's -1, so 3 and -1 is +2, and then this is correct. One tiny little mistake. How to discover it? Well, first of all, don't hurry when you do it, because if you start hurrying, it's always something that you can lose or miss or whatever. And also you can double check your answer. You can put this in the system back, which I really don't like to do, because when sometimes people start checking your answers, it's a long procedure and they start making extra mistakes. But you can check it. You just use the very first equation here. You can check it in the very last equation, for example, because you can plug in your x, y, and z just about in any of these equations, in the first and the second and the third, but you don't have to check all of them. If it works in the very last, it should work everywhere, because the very last one is the one that you actually manipulated the most usually. So let me plug in 2, and I need to put, instead of x number, what we just found, 2, right? Instead of y, I'm gonna use what we found, -2, -2. And instead of z, so it'll be 3z, so it'll be 3 times 1. Z was a very nice one. So question is, are we getting 5 on the other side? We just need to check this out. 4, and that's a +4, and that's a -3. Yes, it works. It always feels good when it checks. It doesn't feel very good if it doesn't check. It means you need to double check all of your calculations. There's some little mistake is involved. That's something that we should do in a case if didn't get it right. So let me do some problems here in the as usual at the end of the section. Let me do one more exercise here with this big systems with 3 equations and 3 unknowns. This always something a little bit more tedious. So here they are. Let me try one here. Let's say 43 exercise. Looks like it's a system that has them all, x and y's and z, and 3 equations and 3 unknowns. So I have to find all of them. And as promised, I'm gonna get some room. I'm gonna share with you a board. So 43. So first of all, I'm going to copy this system the way it is. And of course, I'm lucky that it starts with x, because it is convenient to start to produce zeros under that x. And that's always the plan. You work with your first equation and then use first equation to start with zeros on the second and the third equations, and then see what happens with the last 2. So here's plus z, and that's 4, and finally minus 3x and 2y and minus 2z. Okay. No, yeah, it's plus 2y and minus 2z. So it is very important to, first of all, copy it correctly. Otherwise, you're never going to get the right answer if you were not careful. Okay, so it looks like now we have a good start. So let us copy the first equation the way it is. In fact, I like that it starts with just x, because it'd be convenient to work with it. And if it didn't start with x, you could have switched equations around, because nobody told you that this equation has to be equation 1. Maybe there is another equation that starts with clean x, then you can always put it in front. Maybe we'll do another exercise next time and we'll see that. So what else is here? I'm going to need to use -2, because now my goal is to produce a 0 under x from the second equation. So if I had a -2x and 2x, I would cancel that x term. So I must multiply by -2 my first equation and add it with terms that correspond underneath. So let's do it. 4, isn't it? Minus and minus is plus 4y, and 1y is going to be plus 5y's. If you're not hurrying, it's pretty straightforward. And same with these. 3 times 2 is 6, but minus sign, so it's a minus 6. And you add it with z underneath, it'll be minus 5 times z. Once again, 3 times 2 is 6 with a minus, and 1 it's minus 5. Feels a little better. So next one is a negative 14. 7 times 2 is 14. So it's a minus 14 with 4, negative 10. Some people may say, Alex, you could divide this by 5 and get a better looking equation with smaller numbers. Well, we'll keep this in mind for the next step. And for now, I'm going to work on the equation number 3, right? I need to also start it with a 0. So my goal will be to use a positive 3, right? Because if I go 3x minus 3x, it'd be 0x, and that's just what we need, right? So we don't care about second equation anymore, just the third and still the first one. I say, what if I use the second? Well, the plan is don't get mixed up. So for the first so-called column of zeros, you have to use the first row. That's the idea. Well, turns out from linear algebra. That's where they actually show that. So anyways, I need to multiply by 3 each term of my equation number 1 and collect it with equation number 3. So we're gonna start with a 0, and that will make us feel good, right? 3x minus 3x, I love those zeros. Minus 6, isn't it? 3 times 2. 6 and a minus 6y's, and 2y's is negative 4 times y. Okay, next will be 9. So it's a 9z minus 2z. 9 minus 2 is 7. 7 times z. Okay, whatever it is, we just write it down. And then finally, the right side is 21. 21 minus 10 is going to be 11. This is my new system. And please notice that this equation definitely could be turned into a better looking one, because now my last step would be to deal with this little system of 2 equations and 2 unknowns that we already worked with, right? So if I divide by 5, 5 here, here, and here, because if I start with 1y, that's much nicer. So we're going to have minus 1z is equal to negative 2. Why I want to do this? Well, because the equation underneath, let me copy it, minus 4y and 7z and 11 could be worked out now much more straightforward way. We can kill those y's. We can cancel those y's. When you say, Alex, what about your first equation? You told you need to keep it. Yeah, we can write it down as well. So it's x minus 2y and plus 3z, just formally to make sure it's still here with us. But I'm concentrating on this little system, really. And what I want is to, looks like I can kill the y term. And to do this, I'm going to be, again, copying my first equation, so don't forget. Plus 3z is 7. See, it's a lot of copying to make sure you have a nice structure. You say, Alex, I don't want to copy. You don't have to, but still, you may get mixed up. That's why I'm telling you, and it happened to me a number of times, the mix-up. That's why I don't want that to happen again. So just write it. Just be patient. Do one less exercise, but do it right. I think it's better rather than hurry and do it wrong. In fact, from these exercises, I think if you do one exercise correctly, that'd be plenty. I think that's good enough. You can do the same problem, 43, and that'll be just fine. So remember what we need? We need 0. We have to get that nice 0 here instead of 4y. And how to get 0? Well, times 4 and add it with negative. Notice I always want to have opposite sides. It's more convenient this way. So multiplying by 4 and see what we have for the third equation. And what we're going to have is 7 minus 4, which is 3z. It's a positive 3z. So plus 3z, right? Again, 7z minus 4z, 3. And then negative 8 and 11. 11 minus 8 is also 3. How would you like that? I just love that because I can see what z is. Z is 1. So we produced so-called triangulized system. What? Just triangulized is like if you had imagined this triangle. So there is 3 terms here, 3 equations here. So it's like 3 sides by 3 sides, and everything else here zeros. See, we killed those 2 terms and that, so we produced zeros. That's what called triangulized, produced like triangles, triangle structure. And now we go from the bottom, we get the z. Now we go up to the next equation, to equation number 2, which is y minus z is negative 2. And now I plug in for z whatever we just produced, and we produce number 1. Okay. Takes a little time to write, but it feels good when you solve it. So plus 1 I put on both sides and get y. It looks like my y is negative 1. Super. So now I'm gonna get x. I'm gonna go on the top. So this original equation, x subtract 2y's plus 3z is 7. Now we'll have 2 numbers to replace my y and to replace my z, right? So instead of y is negative 1, okay, let's plug it in. And instead of z is positive 1. So only 1 letter, so we can find it. Looks like it's a plus 2, and this is plus 3. Right, so x plus 5 is 7. So what is x? 2, right? 2 plus 5 is 7. And we got it. This process is heavily used in linear algebra classes. In fact, that's called linear algebra part of this course. So if you like this, this is, by the way, called a like matrix of data, matrix. You probably heard that word. Matrix is nothing else but table of numbers. So some people like to call it various things, but it's table of numbers, a bunch of numbers. So that's what matrix is, and that's something that you're gonna see a little later as well. Just first encounter. And the way to work with these matrices is to make sure that you triangulize them. That's the key reason behind the process. So I don't really want to do another one today because it's going to be way, way too tedious. I think it's good enough if you see this. Now I'm going to go back to the textbook. I'm going to share with you the beginning of this section. And have you tried to do one as a little quiz, but the little one and the nice one. So what I'm gonna do is one for you, like exercise 18, and I'll ask you to do number 17 as a little quiz. So let me do 18 first for you, show you how we could subtract these two equations, right? So x's are going to cancel, and we're going to get y found right away. But be careful when you subtract, because you subtract -7 and -3. When you subtract, its signs change. They get plus, right? -7 and 3 is -4. So you basically get one of these unknowns right away, and now you need to get the other one. So which equation should I use? Well, it doesn't matter. I like to use the second equation. It seems to have little smaller numbers. So don't forget to find the second unknown as well. So if y is -4, fine, put -4 instead of y, like that. And then get x. It looks like x is what, 1? Let's check this out. +4 on both sides, right? So point is, you don't have to do it mentally. You have paper. Do you? You need to have paper for this class and write it on the paper, and that's the answer. So x is 1, y is -4. So just like that, we have solution. What is
Mr.
x?
How do you know why it's 4?
Y is -4? Because
Yeah.
it's correct. Let me write it again. I understand that this is not very visible. I'll write it bigger. So I take two equations, first equation, second. Our goal, remember, is to always eliminate. And this unknown x just begs you. It says, Alex, eliminate me. Okay, I'm going to eliminate it, make it happy. I'm going to subtract it so it disappears. So then I subtract from 2y, 1y, I get y. And what do I get here when I subtract? I get -7, -3, subtracted. Two minuses is plus, isn't it? So it's -7, and 3 is -4. Whatever it is. Just like that. I could use calculator, but make sure if you're subtracting, you need to subtract. If you're adding, you need to add everything, not just one you add, the other subtract. You need to be consistent, the word is. So why don't you?
17 is the quiz.
Yes, please.
All right.
For quiz number 17, you don't need to show me your work. It's hard. You just answer. Just tell me what is x, what is y. So once you found those two numbers, then feel free to relax, because we had a big day with all these big systems. But please don't hurry. Don't hurry. You got plenty of time. Let's put the answer here in the chat as usual. Only to my name, not to everyone. So don't hurry. That's the idea. Or if you want more time to think, you can think and email me your answer later. It's not a problem at all. If you're done, looks like most people done, you don't have to wait, just enjoy the rest of the day. You can log out and enjoy the day. Thank you.
Bye, Professor.
Bye-bye. Thank you.
Have a great day, Professor.
Thank you. Bye-bye.
Bye, Professor. Have a great day.
Thank you. Bye-bye.
Professor, I just have one question.
Mm-hmm.
So after you got -4, you plugged it into the second equation
Mm-hmm.
on number 18, right? Not the top one.
Yeah, I put in the second, or you can put in the first, doesn't matter. It'll be the same answer.
All right. Thank you.
Mm-hmm. You're welcome.
Thank you, Professor. Have a
Thank you.
Have a good day, mister.
Thank you. Bye-bye.